In this video we're going to discuss CRA models for decimal division algorithms. We're going to focus on the standard algorithm. So I'm going to show what the standard algorithm is and then use the concrete model, these base 10 blocks, to kind of help explain this. So our standard algorithm for decimal division is essentially to turn this problem into a whole number division problem. Okay, so we look at our divisor. So if we have 8/10 divided by 5/10, and we're going to show why that's equal to 1 6/10. What we do for the decimal division algorithm is we look at moving the decimal point in our divisor to the right in order to make a whole number divisor. So however many places we move this decimal point to the right, we need to do the same to our dividend. Okay, so in this one, since they both have tenths, we'll end up just with two whole numbers. But even if this had, hundredths or thousandths, we would still just move this one place, since we just needed to move it one place to make a whole number divisor. Okay, so again, kind of the idea, we're going to make a whole number divisor, and then we just use the standard algorithm. Okay, so if we have 8 ones and we want to create 5 equal groups, we can put one of the ones into each of the 5 groups. So we've taken 5 ones away, and that leaves us with 3 ones, and then those 3 ones, we can't place those into the 5 groups equally, so we need to think of breaking those into tenths. Okay, so now we're thinking of this as 30/10. So if we have 30/10 and we want to create 5 equal groups, place those into the 5 equal groups, we can put 6/10 into each of those 5 groups, and that would be all of our tenths. Okay, so why we're able to just use this whole number division algorithm relates to changing what we're viewing as our whole in the model. Okay, so I'll kind of show this first using this idea of tenths, and then show just kind of the switch that we can have in thinking of this as wholes instead of tenths. Okay, so we have 8/10 shown here. I'm going to create groups that have a size of 5/10. Okay, so I can make one group that has a size of 5/10, and then I want this to be represented in terms of groups that have a size of 5/10. Okay, so essentially what I need to do is restructure these hundredths here so that I have 5 total rows. Okay, so I'll need to decompose these since I can't break these apart, but I have 3/10 or 30 hundredths. Okay, so there's 5, 10, 15, 20, 25, and then 30. Okay, so again, this is a full group of 5/10, right? So I would need each column to have 10 of these hundredths in there, 10 of these small cubes. However, each row just has 6 out of the 10, so this is 6/10 of this group. Okay, so there's my 1 and my 6/10. Okay. So why we're able to also think of this as 8 divided by 5, right? So this model was working off the assumption that this unit is equal to 1. So these are all tenths and these are all hundredths. Okay. What we did in our algorithm is we switched the labels, right? We just changed the labels. We shifted everything kind of one unit smaller, basically. So instead of being, or 1 unit larger, so instead of being tenths, each of these just represented 1. So if we have 8 strips, right, divided into groups with a size of 5 strips, here we have 1 group, and then here we have, right, 6/10 of that group, right? Because again, we have 6/10 of that first strip, 6/10 of the second strip, and so on. Okay. What can also be helpful in visualizing why we're able to just change the labels, right? Because this model stays the exact same regardless of what our whole is, right? So whether this is our whole, or if this is our whole, and really if we wanted, we could make this our whole, right? Either way, our model is going to end up looking the exact same. Okay, so one way to think of this, right, if we would have and this will kind of help think of this. If we had something like 3 divided by 2, all right, we know that we could write this as 3 times a half, or 3 divided by 2. Right, so we can, that dividend we can put in the numerator, and that divisor we can put in the denominator. Okay. So we can do the same with this expression, the 8/10 divided by 5/10, even though they're decimals. So we can think of this in terms of a fraction. 8/10 divided by 5/10. So all we did in our algorithm here, right, was we found an equivalent fraction to this initial one. So all we did, right, when we moved this decimal point to the right, was we multiplied the numerator and denominator by 10. Okay, so this creates the fraction of 8/5. Okay. And then I'm not going to show a representational model for this one, just kind of in the sake of time. But again, the standard algorithm for decimal division is to move the decimal point of the divisor to the right so that we have a whole number divisor. Okay, and then even if the dividend has a decimal, we just still would leave that as is, and then we use that whole number division algorithm.